Okay. I just wanted to go through something that came up in lesson. Um, in the intervention session, I should say, and that's regarding units of storage. So, what I mean by this is simply how do we store data? What units of storage do we have? And in particular, what might that look like? How might that look to us? So, what we're going to learn in our objective is to be able to describe why we need to convert binary into other formats. At silver, we can understand that each data unit can convert between different data units. And at gold, we're going to complete all silver and bronze objectives, but to simply carry out some storage calculations. Ultimately, when you think about the units of storage that we have, we can think about things such as like a memory stick or a hard drive or a CD. They're very traditional in their sense, but they are a storage medium in their own right. The thing to bear in mind is that obviously as technology's evolved and things like CDs and hard drives are now starting to phase out, what's important to know is that actually more and more devices are still having their own data associated with them. Okay? And most of them are actually still, in some respects, still having bits of sort of they still require a unit of storage. So, can you think of any more from that's missing from this slide? I think the two that come to my mind are hard drive and SSD. Well, hard drive's on there, but SSDs aren't. SD cards, maybe. So, if you think about a memory stick, you're looking about 4 to 256 gigs. CDs are around 700 megabytes. DVDs are towards the 4 gigabyte range. Hard drives, 500 to 2 terabytes. Actually, I seem to suspect that this figure here, that 2 terabyte, is actually wrong. It's more around the sort of 8 terabyte range now for servers. And there we go. Solid states, DVDs, Blu-rays. Okay, they are all very, very good prime examples of some of these units of storage. Ultimately, the main thing I want you to take away from this is the data forms, if you will, the actual units. And the smallest one that we can think of is a bit. And we know that because a bit is simply a binary digit. It's a mashup of the two words. A binary digit can be either 1 or a 0 and is used to represent data in a computer system. And we know that because it can represent a true or a false value. In particular, if you think about, say, a Boolean expression, you could say, well, the storage capacity of this USB is 8 gigabytes. Well, if we look at the specification that's shown here, actually, oh look, 4 gigabytes. Well, clearly that's not true, is it? So this is actually false. So we could say it's 0. USB type 2 write speed. How about that? Well, if we look again at the specification, we can see that, oh, the type is 3, so in this case it'll be 0. And our write speed is actually 150. Write speed 150. Ah, perfect. This must be a 1. And we can see that absolutely we are right. We can see that we're matching up with our conditions. Think about binary code now. Bits can form binary code, and we know that because it's a unique pattern of bits that represent different pieces of data. Ultimately, we can represent things like letters or symbols from the alphabet, characters if you will. For example, letter A is an 8-bit ASCII binary code and would be represented as a series of ones and zeros, shown here. We can also represent colours as well. For example, the colour red would have a series of, 3 sets of 8-bit binary numbers, and in this case you can see that here. Basically, anything that a computer can represent must be converted to binary. Now, you can pause the video and you can try and work this out. Now that you're back, you're going to want to know the answers. So for blue, for example, you could say it looks like this, and for green, it looks like this. You could sort of use a RGB to binary code converter to figure that out. Now, we know that binary digits, ones and zeros, show that there are only two states. We know that electronic computers and components are by far easier to manufacture, cheaper, and are far more reliable. And actually, we know that data storage devices have fixed capacities. Hard drives don't change. They don't have a changeable capacity. We know they are of that fixed type and are in our computers. Larger capacities are often simplified. For example, we know that TB is just 2000 gigabytes, whereas actually we know that 2 terabytes is just 2 terabytes. We're going to come on to that in just a second. So, the main objective of this is to look at units of storage, and there are a couple of different units that we need to consider. We know that a bit is just a binary digit, 0 for example, but we also have a nibble, and that is 4 bits. In essence, it's half of 8 bits. We know that bytes are 8 bits, and we know that a kilobyte is 1024 bytes. The same can be said for megabytes, it's 1024 kilobytes. Same for gigabytes, terabytes, and petabytes. Just with the previous unit of storage in sort of a more going back on itself sort of way. And you'll see that in just a second. However, we can say that 1024, sorry, we can approximate that. We could say that, just for simplicity's sake, actually, it's more like 1000. So, you've got 0, 1011 for 4 bits, and the 8-bit representation. So for kilobytes, we could just say that a kilobyte is 1000 bytes. Megabytes are 1000 kilobytes. Same for megabytes, gigabytes, and terabytes. Okay. Now here's the thing. We can convert between units quite easily, but we need to remember that you might not want to do it with a calculator. You might want to have that degree of flexibility there. So how do we do it? Well, we know that a bit, it has 2 values and the nibble has 4. So in this sense, I need to divide by 4. If I'm going between a nibble and a byte, I know that 1 nibble is 4 bits. If I times it by 2, I get the full 8. So in this case, what I need to do is simply just, divide by 2. And as we go up, actually, we just divide by 1,000, sorry. What about the opposite way around? What if we're going from petabyte to terabyte, or gigabyte from megabyte? Well, we flip it around. We do the inverse. We could say that, actually, from petabyte to terabyte, we multiply by 1,000. From bytes to nibbles, we multiply by 2. And for bits to nibbles, nibbles to bits, sorry, we simply multiply by 4. Notice how all I've done is I've just flipped my methodology. I've said instead of dividing by 4 if I'm going from bit to nibble, I'm just going to multiply. For example, consider that you've got 1,395 kilobytes in megabytes. How would you work that out? Well, I know that I've got 1,395. I'm going to simply divide it by 1,000, sorry. That gives me 1.395 megabytes. So try and have a go at answering the following. Pause the video and try and see if you can calculate what these would be. Now that you're back, let's try and work through the answers. If we go through them all, we know that if we start from the converting the 1,899 kilobytes to gigabytes, well, clearly we're at kilobytes, and I need to get to gigabytes. So I've got to go from kilo to mega to giga. You can do it like that. I start from kilo. I know that they're both thousands, so I can keep going by thousands. Terabytes to gigabytes. I'm dividing by 1,000 again. So in this case, I'm simply multiplying. And here, I'm simply dividing. Okay. Good. We're not going to do this. You may also be asked about simple files capacities based on files and how that might be stored on a flash drive. So you could be asked to convert different file sizes of different files. So for example, you have homework PNG, video1.mp4, mycat-1. Then you get the idea. How many megabytes are they? Well, we could say that everything has to be configured down to megabytes. In order to get the total, I would then add them all together. So I start from homework.png. I divide that by 1,000. I've got 2.5 megabytes. And I keep going. For my cat, well, it's already in megabytes, so I don't need to do the conversion. And the same applies for bestsongever.mp3. My total is around 1,308 megabytes. Okay, so what you want you to think about here is actually to consider the types of questions that you could be asked. Now, obviously, it's a bit trivial to think about. Well, actually, the questions you could be asked are like this. Okay, so on your screen now are just a handful of examples. Okay, and we saw this chart earlier from our delightful sort of slideshow here, and we saw that actually for bits to nibbles, I am simply dividing. Whoops, why is my pen not working? See if it shows up now. Ooh, still refusing. There we go, it's just very, very slow. But it works better on this. Let's have a look. I am sorry for the technical difficulties. There we go. Let's try that. That might be a bit better. So here we know it's divide. That is far better actually. By 2. Our next line, nibble to bite, we saw that earlier. That was divide by 4. And here for kilobyte down to petabyte, you just divide by 1,000. I'm going to stop there. For a brief second, try and see if we can figure out what MB, TB and PB mean based on what we saw earlier. Now that you've hopefully had a moment just to think about that, MB, I know that the M here just stands for mega, so in this case, mega bytes. I know I've got a gigabyte there, which means that my next one is tera bytes. And for my last one, it's petabytes. There we go. We've done division, and that's done on this side here. But what about the other side? What do we do here? Well, actually we're just inversing it. So in this case, instead of dividing, I would multiply. Ooh, I'm missing an L there. Multiply. multiply by 1,000 and divide by 4, divide by 2. Okay, so hopefully that's solved that sort of question from earlier. What we want to do now is we now want to figure out, well, what if I quite simply just want to just get rid of that. There we go, get rid. Well, now I might want to actually figure out what the answers to these are. Again, pause the video, see if you can work it out. Now that you're back, let's have a look at some answers. I'm going to pull up the answer sheet here, and you'll notice that you might have some different results. So, here we go. How many did you get right? Just award yourself at 1 mark each. So we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 marks. In the real exam, whether you're on OCR or on AQA, is usually worth around 1 mark each. So think about how you might distinguish these in the exam. Think about keywords like convert. Think about your, let's get rid of the keyboard. Think about your different acronyms as well. Okay. Brilliant, that's it. I hope you've found this very useful.